Hello and welcome to the second video in named entity recognition in Python for the purposes of the digital humanities. Now, in the last video, I introduced you to some of the more common concepts of named entity recognition, which falls under NLP. If you've forgotten some of those concepts, you don't really need them for this video, but I encourage you to go back and watch that previous one just to make sure that you have a good grounding in kind of some of the basics. In this video, we're not going to be dealing with machine learning at all. We are going to be dealing with what is known as a rules-based NER method by making a gazetteer and trying to come up with a rules-based method to extract all of the named entities in Harry Potter on a line-by-line or sentence-by-sentence basis. And so what I've done here is I have a collection of data that I don't think I have the rights to share since I didn't write Harry Potter, but I'm going to include a link in the description down below to where you can find all of Harry Potter as a text file. Now, there's a few different resources out there for this. This is the one I chose because it is the cleanest copy of the book I was able to find as a text file. As we're doing this for academic purposes, I don't think there's an ethical problem with sharing this. So the other thing that I am going to just kind of include, because this I do have the rights to share, is a JSON file that I've developed for this one video, which is an entire character list of all the different characters in Harry Potter. Now, I've gotten this list by writing a little beautiful soup and requests web scraping that goes to the Wikipedia page that has a list of all the different Harry Potter characters, goes through and grabs everything in this list, separates all these out by that little dash, and grabs just the names of every single character, both characters that have a first and last name or surname, and characters who only have a single name, such as Dobby or Dobby, Fang, Hedwig, etc. So that's kind of the background of the different data that I'll be working with, and I'm going to be dropping all of this, with the exception of the Harry Potter text, which you see here on the right, on a GitHub repo. The link for that will be in the description down below. And that's all you really need to get started. If you want to learn more about how I grabbed all that data from Wikipedia, check out my videos on beautiful soup and web scraping. But I'm going to skip that for right now and jump into this actual lesson. So if you notice on this directory in Atom, I've got all of my data stored in a subfolder called data. You might not be able to see that because of the screen resolution, but it's there, I promise. So what we're going to do is, the first thing we're going to do is import the library JSON. Now, if you're not familiar with JSON, it can look a little scary at first. All JSON is JavaScript object notation. It's a way that we commonly store data outside of Python to use data inside of Python. And it looks really similar with a few variances to Python data structures. In this case, all we have is a list. If you want to learn more about JSON and Python, I have a whole series, I think of 8 videos on how to use JSON in Python. But for this video, you don't need a complex knowledge. Just follow along and you should be all right. JSON comes standard with Python, so you don't need to pip install anything. So we're going to say with open, and we're going to grab that Harry Potter text first. So we're going to grab hp.txt, and we're going to open it up as R. Now that's going to allow us to read the text file, and this is not necessary for this file, but I'm going to pass in this argument of encoding equals UTF-8. That is my personal thing that I always do, just because it allows for me to use this the same code in a later video or a later lesson and not have to worry about working with data that might be not in UTF-8. Anyways, we're going to say text is equal to f.read. We're going to read that text file in, and if I print off text, you should see it just all come out and look nice and pretty. The problem is I don't want to work with this text file like this. I want to work with it on a segment or a segment by segment basis. So if you notice right here, we have a lot of line breaks, and those line breaks allow us to manipulate the text file. So I can say .split, and I'm going to split this at every instance of a double line break. And what I end up with is a giant list of all of the different segments of this text. So it's a list that broken up into every time there are 2 line breaks. So between chapter 1 and the boy who lived, and between the boy who lived and this first sentence, etc. And it's a nice way to kind of break up a text just to work with it and kind of prototype it. For this video, we're going to just be working with that first chunk of data, this right here, all of that. So if we print that off, we'll see we have just that first line represented, or those first few lines represented. So there you are. Now what we're going to do is we're going to move forward and kind of create a, we're going to import that other data, the Harry Potter characters. So we're going to say data HP characters helps if you can spell it correctly. Characters, there we go. Yep. We're going to read that in. And once again, encoding UTF-8. This is just my personal preference on how I do this as F. And we're going to simply say characters is going to be equal to JSON.load. And we're going to say F. Great. So what we can do now is we can print off that list of characters. Always good to print off things, characters, there we go, just to make sure everything's loaded in correctly before you continue writing your Python script. So we see that it's loaded in correctly. Fantastic. I'm going to go ahead and comment both of these out because I don't really need that anymore, but I'll leave it there, and I'm going to be posting all this code on GitHub for you. So let's start breaking down kind of that text. So let's say I want to break down the text on a segment by segment basis. So we're going to say for segment in text, print off segment. Oh, that was Python 2. There we go. Python 3. And now you can see that we can print off the segment. And because I split this text up and only grabbed that first segment, we're only going to see one here. And that's what I want to see because that's going to make it much more manageable. At the end of the video, I'll change this and get rid of it, and we'll see the same script run over the entire text. So our purpose here is to extract named entities from this text, specifically characters in Harry Potter. So if we look at this, we can easily see that there are a couple different characters. There is Mr. Dursley, there is Mrs. Dursley, and there is the Dursleys, and there is Dudley. So we want to try to grab these named entities. And as you're going to see, the most challenging one of all of this is going to be grabbing the Dursleys. So what I'm going to do is, you can't tell this right now, but the text is not actually cleaned, as we would call it in natural language processing. What you can't see is that there's actually a bunch of line breaks happening right here, right here, right here. That's why it looks nice. While it looks nice to the human eyes, that's actually very bad for a computer to process. So a common practice in natural language processing is to remove line breaks. So let's go ahead and do that right now. So we're going to say segment is equal to segment, and we're going to say dot strip. This is going to get rid of all of the leading and exiting white space, just in case there is. It doesn't look like we have it, but always a good step whenever you're trying to clean up text. Next, we're going to say segment is going to be equal to segment dot replace. We're going to get rid of all of those line breaks, and we're going to replace them with a space. Because if you look here, you have a line break, and you need to have a space, because if you don't have a space, you're not going to have things like made and drills separated. So if I print this off, you should see this now as exactly what we see, one long continuous line of text. While that's more difficult for us to read, it's much more easy. It's easier for the machine to process. Now, the next stage in cleaning up text is to get rid of all punctuation. Now, while this one might not look like that big of a deal, it's actually going to be problematic for other sentences in which we have quotation marks like this, exactly, comma, said Dumbledore, etc. And good common practice in NLP is to get rid of all punctuation marks because they throw things off. It's no different with a rules-based NER. So let's go ahead and do that. I'm going to copy in a little bit of text here, and I'm going to provide a link in the description down below for where you can study this bit of code. Essentially, all we're doing is iterating across all of this all these punctuations and deleting all of the instances of punctuations and creating a new segment each time. And this is going to allow us to essentially remove all the punctuations. Now, this code comes from Geeks for Geeks, but if you copy and paste it from their site, you're going to see a space in there. I've deleted the space because if you don't delete the space, you're not going to have spacing between any of your words, and we want to have spacing there. So if I were to print this off, you'll see that we have the first segment, which is the one that contains the line breaks. We have the second segment in which the line breaks are gone, and we have the third segment in which the punctuation is gone. Notice the period is missing from Mr. Dursley, and then the periods are all removed and the commas are all removed from the sentences, and pause breaks delineated by commas in the actual sentence. Fantastic. The next thing that we need to do, if we're going to try to perform NER, is we need to get the individual words of the text. So we don't want to just kind of analyze this whole text as a whole. We want to break things down typically on a word-by-word basis. And the reason for this is because were I to try to just grab everything, I probably wouldn't really get a whole bunch of hits if I were to just compare it to my list up here. And the reason for that is because in novels and in any text, you oftentimes don't use the character's full name. Oftentimes, you're going to just refer to somebody as Hannah or Abbott, Ludo or Bagman. This is common in most English novels because if you included all the names all the time, it would get redundant and probably be tossed out by an editor at some point. So what we need to do is we need to get words in their individual state and then check to see if those individual words are actually in our list of characters. Again, this is a rules-based method, and it's going to have some flaws as we're about to find out. So what we need to do that is to convert that segment into a list of words. So we're going to say words is equal to segment.split. The split function splits everything up based on white spaces. So if I were to print off words, we're going to see a list. So we have everything right there. Mr. Dursley was the director of a, etc. So we have all the text now split up into individual words. Very nice. I'm happy. So the next thing that we have to do is we have to iterate across those words to check and see if those words occur in our character list. And we're going to notice something interesting here. So for word in words, so we're iterating across all of those words. If word is in characters, print, we're just going to print off the word. And we're not going to have any results. Why did that happen? Well, it happened because we've split up the text into individual words. And in our Harry Potter character list, everyone is represented by their first and last name. So how can we account for this? Well, fantastic, Python can help us out there. If we scroll back up and we look at our characters thing, let's make a new, let's call this character names equals a blank list. So what we're going to do is we're going to iterate across all of our characters. For character and characters, we want to now reduce everything to essentially its core elements. So we're going to split everything up by words in that character list. So let me pull up the character list so you can see what's happening. So we're going to say names is going to be equal to character.split. And that's going to split everything up. But that's not going to be enough to actually solve our problem because this list is not perfect. And I designed it that way on purpose. There are going to be certain problems such as this: Antioch, Cadmus, and Ignotus Peveril. These are multiple names in a single entity because they reference a single person, I suspect. I can't remember this character, but I think that's correct. So what we need to do is we need to say for name and names, if and is not equal to name, and this is going to be a long way to do it, but it's going to be nice to kind of more legible code than if I were to write this as a polished program. And we also want to say and I only know this because I've already tested this out, and the is not name, so it's going to look and make sure that the split isn't grabbing just that. Then what we want to do is we want to say name is going to be equal to name.replace. We're going to replace all instances of commas because those commas will be caught on if we split right there. We want to replace the comma with nothing. And then finally, just to be safe, we're going to use the strip method, and that's going to make sure that all of the names are stripped. And if I just print off name, you'll see what's happening. For character and character, there we go, I misspelled character. Now it should work. And you see all those characters now split up. But we need to drop them into this character's name one. So we're going to do characters names.append name. And now we should have a long list of character names. It's separated by their individual names. So let's do this. So we're going to say for word in words, if word is in character names, now it's going to look for all of these individual names, either first or last. And what do you know? Lo and behold, we run the program, and now it's identifying character names. There's a couple problems here, however, and you might have already noticed them. The first one is that it's not grabbing the Dursleys. I'm not going to address that in this video because by the time I get to this point, you're going to realize why a rules-based method might not be the right solution for doing named entity recognition. in all cases. In some cases, it might work nicely. And the one that we're looking at is the best case scenario, when you have a finite number of characters and you can realistically write rules to identify all of them. So we've got Mr. Dursley. Now that's a single entity. In most NER practices, Mr. Dursley would be a single person because Mr. qualifies Dursley. Otherwise, you might be confused to find another line down, Mrs. Dursley. Mrs. qualifies Dursley. These two preceding titles indicate which Dursley is being referenced. So we need to write a rules-based method for understanding that. So how can we do this? Well, we've got a few tricks we can do in Python. So we can say if word is in character names, great, we're going to keep that. And then what we're going to say is if words, and we need to create an integer stored outside of this loop, I is going to be equal to 0. If words I minus 1, and while we're at it, let's go ahead and just do this, I equals I plus 1. So we're going to increase that counter. So if words I minus 1 is, we're going to call the 0 index. So it's going to look at the previous word in the loop. And if that word has a 0, or sorry, if that word, its first letter, dot is upper, so we're looking to see if it's capitalized, is upper, then what we want to do is we want to say print. We're going to use an F string, which allows for us to format the thing, the string, characters, there we go, that's hard to type today. And we're going to say words, print off words, we're going to say I minus 1, we're going to add a space, and we're going to say word. And then we're going to say else, so if it's not capitalized, then we know that that is probably doesn't have a preceding title or a preceding name attached to it. If that's the case, we're just going to print off word. Again, we're going to make an F string just because this is good practice. And now I'm going to do that so it looks consistent. Found characters, and we should probably put like one of these things there just to be proper in our English. Okay, now when we run this, and we have a syntax error. Lovely. If words, print off words. What's going on here? Ah, I forgot to close the bracket there. I'm used to looking at my screen with a bit, the text a bit more zoomed out, and I missed that. And we have another problem. So what have I done now? I've added an extra one there. There we go. That's what happened. And now everything works peachy. We see that we've been able to look back and grab Mr. Dursley. We've been able to look back and grab Mrs. Dursley. And Dudley, who doesn't have a preceding capital letter, we've successfully identified him as simply Dudley, which, if you look at the text, is precisely what happens. Now, there's certain problems with this method. This method is going to look at the previous word. If the first word, if the first word is a name that's in our list, it's going to look at the last item in the list of words. So there's certain problems with this, but this was just for demonstration purposes. Now, the reason why I went through this whole thing, even though I'm telling you this is a bad way to do it, is to demonstrate the weaknesses of a rules-based search lookup. If you're doing a rules-based NER, while useful for certain tasks, it requires the programmer to write a whole bunch of code to account for a whole bunch of different circumstances in which an entity might be used. In other words, you have to do a lot of code to perform what seems like a simple task. To do the same task, however, with using a machine learning method, only requires about 5 lines of code. And that's what we're going to kind of transition to in the next video. But just for fun, let's go ahead and just run this over the entire thing. And you saw within a split second, I've got every single entity found in all of these different texts. And what I'm going to do is just kind of delete that there. Not delete, but comment out. And we're going to comment that out. We're going to comment that out. And then I can just do every instance of the segment like that. And you'll see every single segment followed by every single character found in that segment. So this is how you do a rules-based NER, and you can already see some of the simple mistakes that it makes. So we've got he, Ron, as a character found, and if you think about it, this is precisely what we told the program to do. Look at the preceding word. If it's uppercase, then it's making a presumption that that is part of that person's name. And in fact, it's not. It's just the start of a sentence. So you can do certain rules that account for that. You can say, if the first word is the start of the sentence, then negate that word. But you can see where this task becomes more and more cumbersome. It is a lot easier and a lot more efficient and a lot more accurate to create a machine learning method, because the machine learning method, as we're going to see in the next video, allows for you to generalize on texts that are not domain specific. So stick around in the next video and we're going to look at a machine learning method for performing NER. And that's going to be it for this video though. Thank you for listening. If you've enjoyed it, please like and subscribe down below.